As each Calvin wave hits the coast of South America, it divides and propagates along the north and south coastline. The speed of the Calvin wave around the Peruvian coast is roughly 200 kilometers per day. The Calvin wave depresses the 20 degrees Celsius thermocline near Peru just as it depresses the 20 degrees Celsius thermocline in the equatorial region. Near Peru, the lowering of the thermocline allows warm, offshore water to flow towards the coast, which results in the Peruvian coastal thermocline deepening even more. Sea surface height data show the Calvin waves propagating north and south along the South American coast. Ocean model data show lowering of the 20 degrees Celsius thermocline near Peru. As a result of the Calvin wave propagation and massive water flow across the ocean, the temperature near the ocean surface increases at the Peruvian coast, and the sea surface height is higher than normal. The two top panels show monthly ocean surface temperature at the Peruvian coast. Red is warm and blue is cold. The left map shows temperature during an El Niño period, and the right map shows average temperature during a non-El Niño period. The bottom panel describes monthly temperature offshore of Lima. The red line is temperature during El Niño, and the purple line is temperature during non-El Niño. You can see the warm water flow from the equator. After December, the Peruvian coast becomes unusually warm. From the bottom panel, you can see this temperature difference is around 5 degrees. The next figure is monthly sea surface height off the Peruvian coast. Brown is high sea surface height, and green is low sea surface height. The left map shows sea surface height during an El Niño period, and the right map shows the average surface height during a non-El Niño period. The bottom panel describes monthly sea surface height offshore of Lima. You can see that water flows from the equator to the Peruvian coast and increases sea surface height. These warm ocean conditions serve to increase the temperature on land. Over time, the land temperature warms faster than the ocean, creating a temperature differential that causes strong onshore eastward winds. The Andes Mountains, which are located along the west coast of South America, obstruct the eastward winds and force them northward. These northward winds strengthen the upwelling process at the Peruvian coast. Since the northward winds are stronger in an El Niño year, the upwelling forces are also stronger. Some believe that the Peruvian upwelling weakens during an El Niño event, when in fact it becomes stronger. Field data confirm this effect. Because of the Calvin wave and warm water flow, the 20 degrees Celsius thermocline at the Peruvian coast deepens. Although northward winds are stronger in El Niño year, the upwelled water comes from above the thermocline. Therefore, upwelling transports few nutrients to the surface layer. Fewer nutrients leads to fewer phytoplankton, as seen in images from the NASA satellite SeaWIFS. This figure shows phytoplankton concentration data from SeaWIFS. Blue is low concentration of phytoplankton, green and yellow are higher concentrations of phytoplankton, with red the highest concentration. The map on the left shows phytoplankton concentrations during an El Niño period. The right map shows average phytoplankton concentrations during a non-El Niño period. The bottom panel describes monthly phytoplankton concentrations offshore of Lima. The red line is from an El Niño period, and the purple line is from a non-El Niño period. You can see the phytoplankton concentration is lower during the El Niño period. The anchovy fishery off the Peruvian coast is the largest and most productive fishery in the world. Historically, scientists have noted that the yearly volume of an anchovy catch off the Peruvian coast is highly correlated to the average sea surface temperature. This figure shows the volume of Peruvian anchovy catch alongside the sea surface temperature at the Peruvian coast. The upper graph shows how temperature differs from the average over the years 1955 to 2000. Red areas are warmer than average. Blue areas are colder than average. The El Niño periods, 1982 to 1983 and 1997 to 1998, are much warmer than average. The lower graph shows historical records of the Peruvian anchovy catch. Note that the largest catch was around 1970 and contained more than 10 million metric tons of anchovies. El Niño periods show a decreased anchovy catch from non-El Niño years because less nutrients, less phytoplankton, and less food for anchovy are available. This makes unfavorable conditions for anchovy population growth and reproduction.